For thousands of years, this mountain slept beneath ice and silence. Now, scientists say it may be waking up again. Deep in British Columbia, Canada's most dangerous volcano is heating from the inside out, melting its own glaciers from below while toxic gases seep through hidden cracks in the ice. What appears calm on the surface is hiding a system slowly building pressure underground. The last time Mount Meager fully erupted, the explosion was so violent it blasted ash nearly 20 kilometers into the atmosphere and sent superheated avalanches racing through entire valleys. Today, researchers are once again detecting signs that the volcano is alive. Steaming vents opening beneath the glaciers, unstable ground beginning to deform, and heat strong enough to carve massive caves deep inside the mountain's frozen shell. But here is what makes this truly terrifying. Mount Meager does not need a full eruption to become catastrophic. Parts of the mountain are already collapsing under their own weakness. And if the pressure beneath the volcano continues to rise, British Columbia could be facing a disaster most Canadians believe could never happen here. Mount Meager is not just another remote mountain hidden in the wilderness of Western Canada. It is part of the same volcanic chain that created some of the most destructive eruptions in North American history. The volcano sits within the Cascade Volcanic Arc, the exact same system connected to Mounts Helens, Mount Rainier, and other explosive giants formed by the John de Fuca tectonic plate slowly sliding beneath the North American continent. What makes Mount Meager different is how easily it has been forgotten. Canada is rarely associated with active volcanoes, and for generations, many people assumed these mountains were ancient, cold, and geologically dead. But Mount Meager has never truly been extinct. It has simply been quiet. Roughly 2,400 years ago, that silence ended violently. The volcano erupted with a force comparable to the 1980 Mount St. Helens disaster. A towering ash column punched deep into the atmosphere, while pyroclastic flows tore through nearby valleys at terrifying speeds. Entire landscapes were buried beneath volcanic debris, and rivers were blocked by collapsing mountainsides. Today, scientists believe the same volcanic system that fueled that ancient catastrophe is still active beneath the glaciers. The mountain may appear frozen and motionless from a distance, but deep underground, the pressure has never completely disappeared. Enjoy deep weather and disaster investigations like this by subscribing now, so you never miss the next major update. The first unmistakable warning came not from an eruption, but from collapse. In the early morning darkness of August 6, 2010, Mount Meager suddenly began to tear itself apart. There was no massive earthquake shaking the region. No extreme storm hammering the mountain. For years, the volcano had been quietly weakening from within, and that night, the pressure finally reached a breaking point. Without warning, an enormous section of the southern slope detached from the mountain. Roughly 50 million cubic meters of rock, ice and debris thundered down into the valley below. The landslide moved with terrifying speed, covering more than 13 kilometers in less than 10 minutes. Entire hillsides disappeared beneath a moving wall of pulverized earth. Dust clouds exploded into the air, while the sound echoed across the wilderness like continuous thunder. The collapse became the largest landslide in Canadian recorded history. When the debris slammed into the Lillooet River, it created a natural dam towering more than 50 meters high. Behind it, water immediately began backing up in the darkness, forming a growing temporary lake with the potential to unleash catastrophic flooding downstream. Emergency officials rushed to issue evacuation warnings for parts of the valley, fearing the unstable dam could suddenly burst. But what disturbed scientists most was not just the scale of the disaster. It was the realization that the mountain had collapsed largely on its own. Mount Meager was no longer behaving like a stable dormant volcano. It was showing signs of deep structural instability hidden beneath the ice for decades. What made the 2010 collapse even more disturbing was the reason behind it. Mount Meager was not simply damaged by weather or erosion. The mountain itself was slowly decaying from the inside out. Beneath the glaciers and rock, an invisible chemical process had been weakening the volcano for centuries. Scientists call this process hydrothermal alteration. Deep underground, hot acidic fluids heated by magma circulate through cracks inside the mountain. Over time, those fluids begin to chemically transform the rock itself. Hard volcanic stone that once supported entire peaks slowly breaks down into weak clay-like material. The structure of the volcano starts losing its internal strength long before any visible collapse appears on the surface. In many ways, the mountain was rotting internally while still looking frozen and stable from the outside. Every year, retreating glaciers exposed even more unstable slopes. Ice that once acted like structural support gradually disappeared, leaving weakened rock hanging over steep valleys with less resistance holding it together. That is why the landslide shocked geologists so deeply. It was not triggered by one dramatic external event. It was the symptom of a long-hidden process already unfolding beneath the surface. Mount Meager had become structurally fragile, and the danger did not end with collapsing rock. The same underground heat system responsible for weakening the mountain was still active. The volcano was not cold. It was alive beneath the ice, circulating heat, gas, and pressure through its core. The collapse in 2010 may not have been the disaster itself. It may have been the mountain's first clear warning that something much larger was still building underground. For several years after the massive landslide, scientists believed the greatest danger at Mount Meager was another catastrophic collapse. But then, in 2016, researchers flying above the remote glaciers noticed something deeply unsettling. Buried within the snow and ice was a strange dark depression that had never appeared on previous surveys. At first, it looked almost insignificant against the enormous frozen landscape. But as scientists moved closer, they realized the mountain was doing something impossible to ignore. The ice was melting from below. A plume of steam was rising directly through the glacier itself. Heat from inside the volcano was punching upward into the frozen surface. Soon afterward, volcanologists launched an expedition into the area to investigate what was happening beneath the ice fields. It's what they discovered transformed the entire understanding of Mount Meager's condition. New volcanic vents known as fumaroles had opened beneath the glacier. These vents were releasing hot gases including carbon dioxide, hydrogen sulfide, and acidic steam directly into the mountain's ice system. Hidden beneath the frozen surface, the volcano had begun breathing again. The underground heat carved massive ice caves deep within the glacier, creating glowing blue chambers filled with toxic air and unstable walls. In some places, the ceilings dripped constantly as volcanic heat melted the ice overhead. The atmosphere inside these caves was both beautiful and deadly. For scientists, this was far more than a geological curiosity. It was physical evidence that the magmatic system beneath Mount Meager was still active. The volcano was no longer simply a weakened mountain slowly eroding with time. It was generating heat, gas, and pressure in real time beneath the glaciers of British Columbia. The images captured inside Mount Meager's hidden ice caves looked almost unreal. Deep blue light filtered through thick layers of ancient glacier ice, while clouds of steam drifted through the darkness below. At first glance, the caves appeared beautiful, almost otherworldly. But inside those frozen chambers, the volcano was releasing something far more dangerous than heat. The air itself had become toxic. Scientists detected high concentrations of volcanic gases, trapped within the enclosed spaces beneath the glacier. One of the most dangerous was carbon dioxide, a gas capable of silently replacing breathable oxygen in minutes. In confined areas like these caves, a person could lose consciousness before even realizing the danger. Another gas, hydrogen sulfide, filled parts of the cavern system, with the smell of rotten eggs a warning sign of active volcanic emissions rising directly from underground. Every breath inside the caves carried risk. The floors were unstable, the ice walls constantly shifting as heat melted them from below, and pockets of poisonous gas could accumulate without warning. These were not simply natural ice tunnels formed by weather. They were being carved in real time by the volcano's internal heat and chemical activity. What disturbed researchers most was what these caves represented. Mount Meager was not quietly cooling after ancient eruptions. It was actively venting heat and gas into the glacier system right now. Beneath the frozen surface, the volcano was still exhaling, still changing, and still capable of reshaping the mountain from the inside out. The growing heat beneath Mount Meager raises a far more frightening question. What would happen if the volcano erupted again? The answer is buried in the mountain's ancient history, and that history is violent. Roughly 2,400 years ago, Mount Meager unleashed one of the largest volcanic eruptions ever recorded in Canada. This was not a slow river of lava crawling down a hillside. It was an explosive event powerful enough to rank alongside the 1980 eruption of Mount St. Helens. The eruption began with massive structural collapse as part of the volcano gave way under enormous pressure. Then came the explosion. A towering column of ash and gas blasted high into the atmosphere, rising nearly 20 kilometers above the mountain. Winds carried volcanic ash across huge portions of western Canada, darkening skies far beyond British Columbia. But the ash cloud was only part of the catastrophe unfolding on the ground below. The eruption generated pyroclastic flows, one of the deadliest forces in nature. These superheated avalanches of ash, gas, and shattered rock raced through valleys at speeds reaching hundreds of kilometers per hour. Temperatures inside these flows could exceed 1,000 degrees Celsius, hot enough to instantly ignite forests and destroy everything in their path. Entire sections of the Lillooet River Valley were buried beneath volcanic debris. Rivers became blocked by collapsing rock and ash, creating temporary lakes and widespread flooding. Even today, researchers can still find remnants of ancient drowned forests left behind by that eruption. What makes this history so unsettling is that the same volcanic system still exists beneath Mount Meager today. The mountain has changed shape over centuries, but the heat source below it has never fully disappeared. But scientists warn that the most immediate danger from Mount Meager may not be lava, or even the initial explosion itself. The greater threat could come from something far faster and far more destructive: lahars. These volcanic mudflows behave less like ordinary floods and more like moving walls of wet concrete loaded with rock, ice, ash, and shattered trees. If Mount Meager erupts again, The enormous glaciers covering the volcano could melt almost instantly from the extreme heat. Billions of liters of water would rush down the mountain, mixing with loose volcanic debris and weakened rock already destabilized by years of hydrothermal decay. The result could become a massive lahar charging directly into the valleys below. And unlike many natural disasters, a lahar gives very little warning. These flows can travel at highway speeds, tearing through river valleys with unstoppable force. Entire forests can be flattened within seconds. Bridges, roads, homes, and power infrastructure could simply disappear beneath a torrent of mud and boulders. Scientists believe the Lillooet River Valley would become the main pathway for this destruction. Communities downstream, including the village of Pemberton, sit directly within the potential impact zone. More than 3,000 people live there today, surrounded by mountains many consider peaceful and scenic. But if a large lahar formed at Mount Meager, experts estimate it could reach parts of the valley within minutes, leaving almost no time for large-scale evacuation. That is what makes the volcano so dangerous. The threat is not only geological, it is deeply human. Its entire communities now exist downstream from a mountain that may already be showing signs of renewed activity beneath the ice. Even people living hundreds of kilometers away from Mount Meager could still feel the impact of a major eruption. One of the most far-reaching threats is volcanic ash. During the volcano's ancient eruption, ash was blasted high into the atmosphere and carried across western Canada by powerful upper-level winds. Scientists believe a future eruption could create a similar scenario, on an even more disruptive modern scale. Vancouver International Airport sits only a short distance south of the volcano and serves as one of North America's busiest gateways for trans-Pacific travel. A massive ash cloud drifting into regional air routes could force widespread flight cancellations within hours. Airports across Vancouver, Calgary, Seattle, and beyond could face major shutdowns as ash spreads through the atmosphere. But volcanic ash is far more dangerous than ordinary smoke. The particles are made of microscopic fragments of rock and volcanic glass with razor-sharp edges. Inside jet engines, ash can melt and solidify, potentially causing catastrophic engine failure. On the ground, ash can damage power grids, contaminate water systems, destroy machinery, and trigger severe respiratory problems for entire populations. Cities blanketed in ash could experience blackouts, transportation paralysis, and dangerous air quality conditions lasting for days or even weeks. What begins as an eruption deep in the mountains of British Columbia could rapidly evolve into a continent-wide disruption, affecting millions of people. That is why experts continue watching Mount Meager so closely. The scale of the threat stretches far beyond the volcano itself. As concern around Mount Meager continues to grow, one unsettling question keeps emerging among scientists and emergency planners alike. Is Canada truly watching this volcano closely enough? Because while Mount Meager belongs to the same volcanic chain as Mounts Helens and Mount Rainier, the level of monitoring is dramatically different. In the United States, major Cascade volcanoes are surrounded by dense networks of seismometers, GPS systems, gas sensors, and satellite surveillance designed to detect even the smallest underground changes. Scientists can often identify tiny earthquakes, subtle ground swelling, or shifts in volcanic gas long before an eruption begins. But north of the border, the monitoring network around Canada's volcanoes remains far more limited. Experts have repeatedly warned that the number of instruments placed directly on Mount Meager is still relatively sparse compared to similar high-risk volcanoes in the United States. While additional monitoring equipment has been added in recent years, many researchers believe significant gaps still remain, and that creates a dangerous uncertainty. A volcano does not erupt on a human schedule. Sometimes it can remain restless for decades before suddenly escalating. Detecting the difference between background activity and the early stages of a major event requires constant, high-resolution surveillance. That is what makes Mount Meager so difficult to interpret today. Officially, the volcano remains under a green or normal threat status. Yet beneath that calm classification, scientists are observing gas emissions, melting glaciers, unstable slopes, and signs of underground pressure movement. It's the disconnect between the official status and the physical warning signs is becoming harder to ignore. Det avgör om tem kon keepia vit von 11 men fide in 220 TTO tuvermexexakimi chi ab. In 2020, another discovery added even more tension to the growing concerns surrounding Mount Meager. Using advanced satellite imaging technology known as INSAR, scientists began analyzing tiny changes occurring across the volcano's surface over long periods of time. What they found was subtle but deeply significant. The ground was slowly deforming. From space, researchers detected slight bulging along parts of the volcano's structure movement, so small it could only be measured in millimeters. But in volcanology, even tiny shifts can reveal massive processes happening far below the surface. The deformation suggested that magma, hot fluids, or underground pressure could be accumulating beneath Mount Meager once again. This did not mean an eruption was imminent. Scientists were careful not to claim that a catastrophic event was about to happen. But the discovery confirmed something equally important. Mount Meager was not geologically dormant. It was still an active, dynamic system responding to forces underground in real time. Combined with the steaming fumaroles, melting glaciers, toxic gas emissions, and unstable slopes, the ground deformation created a disturbing pattern. Each signal on its own might appear manageable. Together, they painted a picture of a volcano slowly changing beneath the surface. What makes volcanoes so dangerous is not only their power, but their unpredictability. They can remain quiet for generations while pressure gradually builds underground. And sometimes, the warning signs are so slow and subtle that people begin treating them as normal right up until the moment everything changes. Yet buried inside this growing threat is a strange and deeply ironic possibility. The same underground heat source making Mount Meager dangerous could also become one of Canada's most valuable energy resources. Beneath the glaciers and fractured volcanic rock lies an enormous reservoir of geothermal energy heat, generated by the active magmatic system, still pulsing below the mountain. For years, energy developers and researchers have explored the idea of harnessing that heat to produce electricity. The Mount Meager geothermal project is now considered one of the most advanced geothermal exploration efforts in Canada. By drilling deep into the volcanic system, engineers hope to capture underground steam capable of powering turbines and generating clean renewable energy for tens of thousands of homes. In theory, the volcano that threatens British Columbia could also help power it. That contradiction gives Mount Meager a dual identity, unlike almost any other natural hazard in the region. On one side, scientists see unstable slopes, toxic gases, melting glaciers, and evidence of underground pressure building beneath the volcano. On the other, energy companies see opportunity, a massive untapped source of low-carbon electricity hidden beneath the ice. But geology does not care about human plans. The same magmatic heat that could light entire cities is also the force weakening the mountain from within. Every sign of geothermal potential is also a reminder that the volcanic system remains alive. And as interest in the mountain grows, the balance between economic opportunity and geological risk becomes increasingly fragile. For now, Mount Meager remains quiet on the surface. Snow still blankets its peaks, glaciers still stretch across the valleys, and from a distance the mountain appears frozen in silence. But the evidence gathered over the past several years tells a far more unsettling story beneath that calm exterior. The volcano is venting gas. The glaciers are melting from below. Parts of the mountain are weakening and shifting. And deep underground, pressure may slowly be building once again. None of these signs guarantee an eruption tomorrow, next year, or even within our lifetime. But together they confirm something scientists can no longer ignore. Mount Meager is not dead. History shows that volcanoes often remain dormant for centuries before suddenly reawakening. Mount Meager sat quiet for more than a century before its catastrophic eruption in 1980. The danger with Mount Meager is not simply the possibility of eruption itself. It is the growing risk of complacency. Generations have lived near these mountains believing Canada was safe from major volcanic disasters. But volcanoes operate on geological timescales, not human memory. And sometimes the most dangerous phase of a disaster is the long silence before the system finally awakens again. Subscribe now for more deep weather investigations, volcanic threats, and real-world disaster stories shaping our changing planet every day.